Dear colleagues and friends, in today's rapidly evolving digital landscape, companies face the urgent need to adapt quickly, implement new solutions, and enhance user experience. But how can they create a system that remains flexible, scalable, and ready for change? The answer is MEC architecture. This approach is built on four principal keys. On four key principles: microservices, API first, cloud native, and headless UI. During this presentation, we will explore how MEC helps companies like Nike, Netflix, and Amazon build innovative digital solutions. You will discover the advantages of MEC over monolithic architecture, as well as where and how this approach can be applied to business growth. Our first slide is what is MEC? What is MEC? MEC is an architectural approach that makes digital solutions flexible, scalable, and adaptive. It includes four key components: microservices, independent system modules, API first, seamless interaction between services, cloud native, data storage and computing in the cloud, headless separation of backend and UI. Why is this important? It allows businesses to quickly adapt to market changes, enhance the digital experiences for customer, and easily integrates new technologies. So the first part of MEC architecture is microservices. Microservices. What is it? Microservices are small autonomous parts of a system, each performing a specific function. For example, Netflix uses microservices for movie recommendations. One service manages user data, another analyzes preferences, a third handles subscription and payments. The advantages of using microservices are flexibility, which means individual modules can be updated, reliability, a failure in one component doesn't break the whole system, and scalability. Specific services can be scaled independently. API, yes, microservice, API first. And the next part is API first. What is API first? API first means that all system functions are accessible through an API, which serves as the central link between different components. Unlike traditional development approaches, where the API is built later, API first architecture designs the API at the very beginning, ensuring maximum flexibility and ease of integration. This approach guarantees that all services and platforms can seamlessly exchange data and interact without major code modifications. For example, Amazon Alexa, the voice assistant, connects to various services via API, retrieving data and executing user requests. Smart devices, mobile apps, web services, smart speakers, and other gadgets use APIs to access information and perform actions. Rapid integration of new technologies. Companies can implement cutting-edge solutions without overhauling their entire system. And what are advantages we get? Easy integration of new services, efficient interaction between components, universal access, data. Yes. The next is cloud native. So, what is cloud native? Cloud native refers to an approach where applications and services are designed specifically to run in cloud environments instead of traditional local servers. This system leverage cloud computing resources to provide high availability, scalability, and flexibility. Unlike legacy infrastructure, cloud-native systems are built to dynamically adapt to changes in demand, supporting continuous development, deployment, and scaling. For example, how Spotify uses the cloud. Music storage in the cloud. Instead of storing millions of songs of physical services, Spotify uses cloud storage solutions to ensure instant access to music worldwide. Automatic scaling. When more users stream music, Spotify scales its resources automatically to handle peak traffic, ensuring smooth playback. Stable streaming. Cloud infrastructure minimizes service downtime and ensures a seamless listening experience, no matter the number of users online. Beyond Spotify, cloud-native architecture is used by Netflix, Uber, Google Drive, and other global platforms to efficiently manage workloads at scale. What are the advantages of using cloud-native? High-speed performance, flexibility and scalability, and data security. Headless. What is headless architecture? Headless architecture separates the front-end UI from the back-end, logic and data processing, allowing them to interact via APIs. Unlike traditional systems where the backend directly controls the interface, headless architecture gives businesses the flexibility to manage and display content independently across multiple platforms. With a headless approach, companies can seamlessly deliver their services across websites, mobile apps, smart devices, and even voice assistants, all connected to a single backend without rigid dependencies on UI structure. Next, we will analyze the working algorithm of Mac architecture using its application and e-commerce as an example. This will help to understand how Mac addresses key technological challenges, ensure components independence, and simplifies the integration of new services. The first step data request. What happens? The client, web app, mobile app sends a request to the API. The request may relate to fetching product information, orders, users, or analytics. The API gateway receives the request and determines which microservice should process it. What are the key points? API first. The API is designed first, followed by service and interface integration. Front-end is independent from the backend. Different interfaces can connect. The next step, request processing. What happens here? The API forwards the request to the relevant microservice responsible for data processing. Each microservice performs a specialized function. For example, product catalog management, payment processing, user management. If a microservice needs data, it interacts with other services via API calls. What are the key points of microservice? Of this step? Microservices. Each service is independent and autonomous, meaning a failure in one service does not break the entire system. Separation of responsibility helps manage project complexity since servers remain independent. Data access. What happens here? If the request requires data retrieval or updating, the microservice interacts with databases or cloud storage. Data can be stored in distributed systems like SQL or NoSQL. Cloud infrastructure such as AWS, Google Cloud, Azure may be used for automatic scaling. What are the key points? Cloud native. The platform operates in the cloud, ensuring reliability and flexibility, and it allows the use of various databases and distributed storage solutions. The next step is client response processing. What happens? After processing the request, the microservice returns data to the client via API. The front end receives the data and decides independently how to display it. Unlike traditional systems, Mac architecture backend doesn't control the UI, it simply delivers data. What are the key points? The UI is independent, allowing multiple front ends for a single backend. Developers can use various technologies such as React, Vue, Angular, Flutter, and the others. scaling and system updates. The next slide is, and what happens here? If system load increases, microservices can be scaled independently. For example, if order volume spikes, the service responsible for payment processing can be scaled up accordingly. System updates occur without downtime, as each service can be updated individually without restarting the entire platform. What are the key points? Service for individual microservices can be increased as needed, and the developers can roll out new features without affecting the entire system. And yes. So conclusion: why businesses should embrace architecture? Now we compare Mac vs monolithic architecture. Well, monolithic architecture is a single application with tightly coupled components, difficult to update, and changes affect the entire system, and limited scalability. While on the other hand, Mac architecture, independent microservices, updates can be made locally, easy integration of new technologies, and high scalability. Where is monolithic architecture used? Internal system that do not require frequent updates. Where is Mac used? E-commerce, streaming, SaaS. Yes, and where to apply? Where to apply? Where to apply? When is Mac better? For Mac better for businesses that require repeat feature updates, companies operating in high-load environments, and e-commerce, AI platforms. Where is monolithic architecture better? Internal corporate systems, small projects that do not require complex integrations. So, key reasons to transition to Mac. First is flexibility. Mac architecture allows businesses to implement quick updates without disrupting the entire system. Each microservice operates independently, so changes can be made at the local level without affecting other components. This is especially critical in today's dynamic market, where the ability to adapt rapidly is a key success factor. Integration. Thanks to the API-first approach, Mac architecture enables seamless connection with a wide range of technologies. Businesses can integrate third-party services, machine learning solutions, analytics, and other innovative features without complex modifications to the core system. This ensures technological agility and long-term scalability. Scalability. Cloud-native infrastructure ensures that Mac-based platforms can automatically scale according to demand. Whether a company experiences a sudden surge in traffic or needs additional resources for seasonal promotions, cloud scalability allows for optimal performance at all times, reducing downtime and improving reliability. User experience. A headless architecture ensures a consistent and seamless user experience across all platforms. Whether customers interact through a web app, mobile applications, smart devices, or voice assistants, Mac enables businesses to provide a unified and personalized interface, boosting engagement and satisfaction. Cost optimization. Traditional monolithic architectures often lead to high maintenance costs due to system complexity. With Mac, businesses optimize expenses by reducing infrastructure overhead, avoiding expensive updates, and streamlining development workflows. By using modular microservices, companies invest only in the technologies they need while eliminating unnecessary resources consumption. And the conclusion is, companies adopt Mac architecture, gain a technological advantage, staying ahead of competition and ensuring long-term sustainability in the evolving digital landscape. On the other hand, businesses that continue using traditional monolithic systems risk falling behind, struggling with limited scalability, slow innovation, and high operational costs. By transitioning to Mac, companies position themselves as forward-thinking industry leaders, ready for future challenges. The choice is yours. Embrace innovation or fall behind. Now is the time to become a technology leader and fully harness to the potential of Mac. Ready for change? It's time to act.